Hey there, physics students. Mr. Phelps here. So we're on Kinematics 2, which is for Unit 2 activity, and of course activity. So I'm going to show you guys how to do this. Would not be as difficult as Kinematics 1 was. Looks a lot easier. Still, wouldn't hurt to see it. So introduction's right there. You guys see that on your own. Going to be plotting here is the evaluation. You guys, of course, see that on your own. Lots to it. And so that's your standards by which we're going to grade you guys on rubric-wise. All right, now, oops, let's get out of this. So when you guys get to it, you're looking at Unit 2, Task 1 about projectile motion here. So again, you have a video. So like you do in all your other assignments, click the snowboard, jump in this case, the blue stuff. Click on those, and you're going to see a kid in a video start jumping. So let me show you what it looks like. Most time was spent on this. So here's a video. You're going to click the play button right there. So it's a duration of a total 1 second. So the first set of directions is going to ask you to plot those points. So we're going to plot the legs. So legs here. This is the x-axis, which goes left to right across the screen. Okay, it shows that motion. You guys notice from your tutorials that left to right is x, and the y motion is going to be going down. There's two components to projectile motion, vertical and horizontal. So it's going to ask us to plot. So let me go to. Let me pause this actually for a second. Now, of course, in part A, you have to describe what you saw. I forgot to talk about that a little more. Just describe what you saw happen. I want more than one sentence for that. Just observe. Don't say somebody just jumped. Okay, somewhere jumped. Were they on a ramp? What happened? What kind of motion was involved? I brought two things up earlier. What kinds of motion involved with this? What's it called if an object follows a parabola? So let's keep it like 2, 3 sentences would be fine. All right. So I'm looking for now. Part B, that's going to be looking for you guys to do the plotting I brought up earlier. So we're on the legs up here, like I said earlier, and we're going to start running the video. So we're going to go frame by frame. So you see, these are all before they leave the ramp, this person. So what we're going to do, we're going to start plotting points. So that's time 0 right there, it's on the board. Now we're going to go frame by frame using this button right here, step forward, 1 frame at a time. Now you have to hit the shift button, so it says shift there. So on your keyboard, hold shift, and then you click right there, best you can. And then it goes frame by frame on its own. You don't have to do anything at all. Just every time you click, it'll advance 1 frame. And you see below, it's plotting every 1/10 of a second the x, the y, the velocity of x, velocity y, unit acceleration for x and y directions. So finish rest these up. And it's like 10 frames I think you're doing here. Again, shift every time. If you don't hit shift, if you don't hit a shift, you click on that, nothing will happen. See, I'm hitting that, nothing happens. But I've hit shift, that goes green. I can see that, so I got it on. And be as accurate, or I'm sorry, as precise as you can. Click it right in the middle of that circle. And not sure how good I did, but and then after 1 second, it should be all done. So you see right here, we're done. Now, next step. Now, before I go through and plot like I just did, one thing said in directions I forgot to mention you guys could do. I don't think you'll need to do it, but you guess you could. It says you guys advance the size to 125% to zoom. That way it's supposed to make it a little easier to plot the points. You can do that. That's up to you. I didn't do it, but if it makes it easier to see to actually hit those spots on the points, that's fine. Okay, I'll leave that up to you guys. All right, so we have our data that we're going to be using throughout the activity. So at this point, it's asking you the question. So let's go back to the question here. So let's go down here. So how do the two graphs of x versus t and y versus t appear? So what the graphs look like, and what can you say about the displacement of the snowboarder? Displacement means how far they traveled every given frame or every 1/10 of a second. So let's go back to here. So we look at x versus t, or the time versus this displacement in the x direction. Notice we get a nice straight line, and there's a name for that kind of line. I think you guys know what it's called. So you got to identify that line, what it is. Also, if you look at y versus time, notice we get a shape of this. So in your answer for part B, you must describe the shape of both graphs, right? So I'm looking for certain types of words right there. and the answer. Now you should already know from your graphs you did earlier, you've read about in tutorials. What else we got here? And type of the distance when traveled, the intervals, the distance covered every tenth of a second, are those the same, the different, um, as well as what else we're looking for right there? Yeah, that. So the shape of the graphs also, what's displacement look like? Get them intervals. Now go to part B. It says observe the graphs of the horizontal and vertical components of the up and down, the left to right, uh, velocity now, not displacement or distance traveled, but now we're looking at speed basically or velocity. So on the well, it says directions. So click on the XT graph, click on the X. That's like V of X. Do the same thing other graphs. So I'm looking for V of Y. So let me show you how to do that real quick. So we go back to here. So here on the X to T graph, right there, click that. You want V of X right there. And then other graph, you're going to click the Y. You want velocity of sub Y, which is right there. So look at the two graphs, and we do see they're not really nice straight lines either. They definitely have a pattern to them we're looking at. So on part C, it says, what do you observe about the velocity components of the snowboarder before and after time zero? Well, time zero, let's see if we can click on this. So we have what total of 11, 12, 13, 14, 4. So actually the fifth point is time zero. So actually the fourth point is time zero. 1, 2, 3, 4. So here's time zero there, and there's time zero right there. So what do we see happening here at the x-axis, and then after 0 seconds starting, and then also here, time zero is right here and here. So look for a pattern right there. So what do you observe about the velocity of components before and after? So before time zero, so these first four right here is before, and after the ones at the fourth dot. Okay. Now one thing you should notice about these two graphs right here is that they're not what they should be. Basically, you should learn back early in the unit is that you should get nice straight lines for the x because velocity should be pretty consistent. It's almost get a straight line here. It should almost be linear, and you're not getting that. And then over here for the y, you should get generally the shape right here, kind of a curve, but it's a little bit bumpy. It's not quite as a smooth curve like it should be, like almost like part of a parabola. So looking at that, so it's not quite looking for. So in your answer part C, you should discuss how what you should be looking for, what should be, and then versus what you do have, the difference between the two. Your observations aren't really jiving what you're supposed to have, right? So it looks like they're okay at, especially this one down here for V sub Y. It looks great at first, and then most is pretty good, but it's not really a smooth graph down here. Then up here after time zero, this even before that, it's a little bumpy still. So you need to talk about that in part C. Moving on, part D. Now in part D, you're supposed to change now from velocity now to acceleration. You go to here, click that. You want a sub x. So acceleration looks crazy. And then change the velocity y to acceleration of y, or right there. Whew, those graphs don't look right, do they? So, for x, if you remember projectile motion as a object is going, there's two components of projectile motion, vertical and horizontal. So up here we have a horizontal motion. That should almost be a straight line. Okay, linear, should sort of linear relationship. But you got a roller coaster effect going on here. That seems very odd, doesn't it? If you look down here for y, now that should be a straight line, linear as well because we don't think as things fall, they drop at 9.81 meters per second squared as they drop. So the y component, and still a snowboarder, you can see up there, just they drop. So watch it again. They're dropping the whole time. Once you get to peak, and then they start dropping. But this part of the motion, the horizontal, should not be changed. That should be pretty consistent. But according to this, is not consistent. All right, so in part D, you need to talk about what you should be seeing versus what you did see. These graphs don't look right. Okay, so a sub x, this should show a consistent, almost consistent acceleration. Should not be much. It should almost be a flat line. Where this should be almost a linear line, linear as well, but should be showing a downward slope and be a straight line as well. Now, before we answer part E about the legs and how that handled your, how that kind of change your motion to look at, why don't you watch this little video real quick, just a short one from IT. Place full of smart people. Make it a little bigger. So this kind of point is tossing things through the air, but in an arc, in a parabola. As you kind of notice, those things he's throwing, the mass is actually on one end. Not easy to notice right there. But then the same objects, but you paint them with some orange paint and then throw a black light on it. Kind of cool. You can see they follow a curved path. When you only see this where the center mass is, you can see it follows a nice curved path at that point. That wheel thing. So as you can see, the center of gravity. Okay, so look back to part E real quick. So see that everything's the legs. If you play the video back real quick, let me go back, start over again, right there. Okay, watch some more his legs. They're not going to stay nice and straight. What do they do with their legs? They bend the legs, then they elongate them again at the end to soften the cushion to fall. That's why using legs really isn't a good idea. All right. So you want the more the center of gravity in the person is actually easier to use. That's a question he's talking about. So the question he uses from observations of the horizontal and vertical motion or positions of the motion for velocity and acceleration. Do you think using the legs on the snowboarder as a reference point for plotting the motion is a good option? Okay. And now just give me yes. I don't want to see just yes or no. Okay. I just talked about it. Think of what I talked about. Okay. You want something that's going to be kind of stationary, a stationary point on the object you're measuring. If it's not stationary, if it's moving around, it's changing shapes, that's an issue. So maybe bring that up in your discussion part E. Now task 2 part A. So we're going to actually change some things. In directions above, they're not showing directions right there. You guys can see it yourself, but you do have to make some changes. So I'm going to show you guys how to make those changes real quick. So up here, it's going to tell you to click on the blue arrow thing right here. Select that. And you want to also pick legs. I'm sorry, you'll get legs, but pick head. And then I'm going to pick tail. All right. So I already got those selected. And later on, it's ask you also to click a center of mass. So create a center of mass. Okay. And I already got all three of those there. And it says also when you guys pick the, you want to use, I was called centimeters. I think I already, okay, this should be center mass, not centimeters. For Y. Then over here, clicking on center mass, you select all three. It's just say centimeters up there automatically. Tail, legs, and head. And I'm going to create center mass there. All right. Then it's supposed to move this to about where I think the center mass would be, which for most people is right around your belly button. So I'd say somewhere in there. System I'll get around 0, which I've tried to get to 0 and I just don't know how to get to 0. It never quite gets there. So I'm gonna leave it that spot right there at that point. All right, so then we have to go to here. We gotta select the where we got the legs. Let's get the head in there. We'll click visible. And actually, before we do that, let's go back to the here. Actually, it's frame 0. And jump ahead to frame 0. So we notice this follows a nice little parabolic path their center of mass does. Now graphs, the way the directions are given to me is not supposed to look exactly like this. What we should be seeing for the graph of the top graph for acceleration of x is a constant acceleration, right? So basically, it's actually not constant, but it should be no acceleration. It should not be accelerating as you go across this way, but as you go down, there should be increased acceleration. And it's kind of looks a little, it's consistent, but it's more of a straight line here than what we're seeing. So the graph's not looking the way they're saying it's supposed to look. But for part A, I'm looking for is you should notice in the top graph, time versus the acceleration and of x motion or left to right horizontal is constant. There's no acceleration. But as you go down, you guys already know things fall. They should gain speed. That would cause the path to actually go downward like this because you have the y component. It should be a constant acceleration about 9.81 meters per second squared. So the graph should be showing that. Not quite seeing that, but at least in your answer part A, reference those. Okay, next step, we're supposed to change these graphs here with the velocity of x, so v sub x, and the v sub y, which is right there. All right, so getting those graphs now. So these two graphs are here. The top one, this is based on the velocity of x and velocity y. So now velocity of x is supposed to be pretty consistent. It looks pretty wavy according to the graph, but according to what I'm told, the answer key is supposed to be pretty constant velocity, which does not appear to be constant velocity to me. But this graph down below does look pretty consistent. Looks like velocity is increasing as you're going down. Should be as you fall, should be getting faster and faster. So that does make sense. So in part B, we can talk about that, about the shape that at least what's supposed to happen in part up here in this graph, what's supposed to be showing, and what's actually being shown here, which is actually correct. Okay, now in part C is stating from the graph of the horizontal velocity on the top graph, what can you say about the horizontal displacement of the snowboarder after they leave the ramp after the fourth point? Well, it's supposed to be a constant velocity we're looking for right here. Okay, it should cover equal distances in equal time, even though it's not looking that way according to my goofy graph I got here. Not sure if it's directions are off or what's going on there. All right. Now in part D, you can look at this, do the same thing, but do it with the vertical now. All right. So this one will let you guys do a little more on your own. Okay, so at least you have a decent graph here. So talk about what's happening to distance over time. All right. Let's talk about and how that relates to the velocity. So then here for part D, just looking for what's the acceleration velocity going on right here. Talk about displacement every given second or tenth of a second, and also what's happened to the acceleration as they proceed along through time. All right. Now on part E, in fact, let me go to part E so we can see that together. Back down to part E. So base your analysis of where's motion. How do you think you get even better results from the center of mass measurements like this one? Well, one thing we're looking for right there, if you actually could find the true center of mass, because it's not the same at point every person, is roughly around the belly button area, but it just changes based on taller people, shorter people, make it a little different. So we talk about the center of mass could be different based on more than just 3 points, more than just the tail, the head, and the legs. All right. Um, so talk about how they could actually get better results. That's not going to be a very easy question. Just do the best you can. I'll be a little forgiving on the answer. Okay, look at task 3 finally, part A. So got the general equation right there. So you throw that back in your, let me look at here, in your tutorial, which is there. And specifically saw this equation right here. So what you're looking for is, so it was in slide 19. So going back to this. So we have the original position, we have the velocity and the time of the object in the x direction, displacement, and then you have acceleration. This is all for acceleration here. So I want you to simplify the equations. So explain how you can simplify for the general displacement equation. Well, what I'm looking for right here is the original position is 0 right here. You're starting from point 0, so you really just take the x sub o out right there. And then here, you can just, that's good because they're going to be moving with a given time once we leave the ramp. And then there, we talked about earlier, there's no acceleration when he leaves. So there's nowhere leaves the ramp, there's no acceleration. So at least only one part of this equation is still in there. So what will x equal now? So I'll let you figure it out what I just told you there. Now in part B, you can do the same thing. Now it's in the vertical, do it the same way. All right, so he's thinking, so how's somebody's equation? So when he first begins falling, you gotta think, what was this, what was time 0? So this is actually y sub o, that would be 0 anyways. So probably really don't need that, okay? But then he does have a vertical velocity and he is going to be changing, he's going to be accelerating. So there's parts of that equation you can still keep. So kind of gave that to you, so go from there. Now let's go on to part C. It says to Get numerical equations for x and y. You need to know the initial values at time 0 when we first began, when they first left the ramp. For some velocity acceleration on the table below the video, we want to click centimeters, and then you also want to check off for the x and y, xy, v sub x, and v sub y, and then hit close. Okay, let's go to the video again, right here. So here, click this, we want centimeters. X and Y actually, I kept saying X and Y, but for the equation, you're going to actually want these values, negative 5.971, because if you look at the equation, he wants the velocity, not X, Y positions. So for me at least, negative 5.7971, and for you guys, it'd be something different, be close. So, and for my V sub Y, velocity Y, 1.179 at time 0, right there in the end of the ramp. Okay, so next step, I think we made our table. We'll get that done. And we get that all taken care of. Yep, did that earlier. This is next day I'm doing this, by the way, so if you wonder why I'm going back to it, I just couldn't remember if I did that in the last video, so I did. Okay, let's move on from there. We got to go to part D. So part D, scroll down here. Now, in part C, we should already have the equations. You got to write the equation out. Like, substitute your values in. For me, it'd be negative 5.971 for my v sub xo, and then my time, just leave t there for the time being, okay? And then my y, that'd be again, that'd be the velocity of at y times t plus 1/2. Now the a value when you do part C, a value is going to be 9.8, the acceleration of gravity which you want. So when you use that, and then so 1/2 of that times t squared. So if you get confused about what I'm talking about, the equations, just ask me later on. But that all should be in your structure. You guys want getting rid of those equations. I'll keep going back at that. But anyways, yeah, you're gonna have these find x and find y using equation I showed you earlier. Now on part D, so let's go to part D real quick. Okay, now the analytic particle model. So that we'll find using one second. Okay, so all the directions are right there. I'm going to try to follow as best I can. Not the easiest directions. These aren't as bad as some of the directions we had earlier. So, okay, so go up to here. It's arrow. And so, hold on. So, parameters here. Again, mass 95 kilograms. I lost it. So, okay, the expression for just keep it value 0, want times 0 anyways. And then we're going to put expression. And we'll use a negative 9.561, then put the asterisk sign and place the multiplication sign, t. And then for this, for y, I had a 1.179, so I want to take 1.179 times t, and then add to that, plus, and then, I'll make sure I don't leave any blanks there. That might be an issue. Plus, parenthesis 1/2 times, then we'll use 9.8. The acceleration variable 9.81. We'll hit times t, then use a caret key. This program, which is, I gotta find it. You guys use it all the time. I don't very often use it. Let's see where I find it. I found the caret key. Sorry. All right, so caret, and then I got square the times, so we use a 2 there. All right, let's see if this worked. All right, got that. Okay, it looks pretty good. Now it says run the video in the directions, so run the video. And those blue dots represent our points every 1/10 of a second. Okay, that looks good. So for part B, then we're looking at this is the x versus y. Notice you have a nice linear graph. Now for the now it's using center mass, and also for the y, you have a little curve to it, which that makes sense. You're going to actually, as you go down, as you go farther and farther, you're going to accelerate. If we look at the say velocity of x, Velocity is pretty consistent. That makes sense. So the velocity is as you go in the x direction, you should not really change speed at all. That makes a lot more sense than we had before. And then the y, that velocity should be increased a little bit. Let's see, velocity y. Yep, that's increasing also. So we have a constant acceleration right there. So we should be covering more distance in a given time or going faster as we fall. So these graphs make a lot more sense than the earlier graphs we had. When we look at acceleration of x, that looks goofy. Let's look at acceleration of y. That should be pretty consistent. Yep. And it shows no acceleration. So it's accelerating, but it's no change of acceleration. So it should be pretty consistent. That's almost 9.8 right there. So it looks pretty good right there. 9.8, just short of 10. That makes sense. So yeah, so our values make a lot more sense than we had before. It's great. Part D, I wanted you guys to, let me go back to part D here. I want you guys to, up here, describe in what position the model point varies from the center of mass point. Now, the model point, the last one especially in directions that lie from center of mass, and assume how would you modify the V and X. That seems pretty complex. So let's go back to this. If we play the video back, oh, so this, we're talking about the model point is right up there. And then the center mass is right there. And then if we click ahead, and when they land right there, it looks like it's a little bit to the right. So we can say that the model point is slightly farther to back or farther right than the center mass is. I don't know. Actually, it's almost dead on, really, I guess. If you look above, it's almost dead on. Far as right there. And then what else asked for? It's asking for that question. So back to I'm looking at here. And then the y is off a little bit. So yeah, your x is almost dead on. Your y, of course, is off. But yeah, so I'm looking for in part D. Just note that the center of mass is a little bit to the right. The model point is a little bit to the right of the center of mass point, and it's definitely well above it, which is what's supposed to happen. So it's definitely not where it's supposed to be. It's way up here instead of down here, which is fine. All right, that's pretty what they say. And at closer, you can just talk about you can change the v and the x a little bit, and the action might get a little closer where we want to be. All right, so not a whole lot to write down for part D there. All right, now going to part E. Part E, honestly, they just want you to change some things by maybe a tenth of a meter per second, the velocity. I'm going to tell you guys, it's almost all the same numbers pretty much, just slight variations. I'm going to tell you guys not to worry about it. So I'm going to let you guys skip part E. Let's make a note in your on your assignment that I told you to skip it. It's just not much difference, and it's going to be seen there. And then part F, it's about being a sportscaster. At the Olympics, you create a mathematical model similar to one that we just did. Imagine you had a computer program. No, most of the Olympics going to do that. No sportscaster will. That could be, but anyways, yeah, how the computer program that could essentially analyze the video motion that the model use. How can you use it as a sportscaster? So just about how sportscaster might be able to use it. Keep it research a little bit, but I don't expect more than like 2-3 sentences from that. All right, so maybe in your answer talk a little bit about oh a boarder can't use do a whole lot change their projectile path because because it's based on center mass. And as long as the x and the y are consistent, then you should be able to pretty much predict what path they're going to follow. As long as their velocities at x and y. So maybe throw something like that in your answer. That's pretty wide open there. All right, now I think that's about it for the assignment. Oh my God, thank God. Whew, that was a tough assignment. So I thought it would be easier, but it get a little harder at the end. So if you have any questions, please contact me. I'll try to help you guys out a little more with this. All right, so I'm going to close it out, and please contact me if you have any questions. All right, goodbye.